So, today I will discuss about the polarization by double refraction. What is that polarization by refraction? Basically, medium we can divide it into two types. One is called isotopic medium and another is called anisotropic medium. Okay. So, these are general term, isotopic and anisotropic general term. So, for any property the medium can show the isotopic property or anisotropic property. So, in this case about the velocity of light through the medium, whether in all direction the velocity of light is same in the medium or not. If velocity is same in all directions, so then it is called the isotopic medium. If velocity is not same in all direction, then it is called anisotropic medium. Okay. So, velocity same in all direction means it is called the velocity spherical, and velocity is not same in all direction is called velocity ellipsoid. Okay. So, common material for refraction is the glass material. This material is basically isotopic material. Its velocity is same, velocity of light is same in all directions. Okay. But there are some transparent crystal is basically calcite crystals and quartz crystals. They are like glass. Glass is not crystal, but this calcite and quartz, they are crystal, but they are transparent like glass. So, in this crystal also we see the refraction, but the refraction, that is, or the velocity of light in this crystal are not same in all directions. So, it is the anisotropic medium. Okay. So, velocity depends on the basically refractive index, or refractive index is defined by the velocity of light in the medium with respect to the velocity of light in vacuum. So, refractive index, basically velocity of light, depends on the direction of light as well as direction of electric field. So, that is basically polarization state. Polarization states are two types, either sigma polarized state or pi polarized state, right. So, these crystals are called double refraction or birefringence crystal. Okay. So, calcite crystal and quartz crystal, there are other crystals also. So, they are called double refraction crystal or birefringence crystal. Okay. So, we will discuss about basically we will keep our discussion with this calcite crystal and quartz crystal. So, these two are again it is the uniaxial crystal, means uniaxial crystal means that in one direction there is in one direction the velocity or refractive index or whatever that is different than the other directions. Okay. So, that is called uniaxial crystal. So, in one direction it is different, but other direction. So, if you consider the mutually perpendicular 3 coordinate x, y, z Cartesian coordinate. So, in one direction this property are different than the other two directions. So, in other two directions property are same, refractive index or velocity they are same. Okay. So, that special direction, that is called basically optics axis in this crystal. So, there is uniaxial crystal, there is a special direction, okay, axis. Okay. So, that direction is called optics axis. So, these crystals have only one optics axis. Okay. So, but there are some other crystal like mica. Mica is a biaxial crystal, means it has two optics axis. Okay. So, we will not discuss about the biaxial crystal. So, we will limit within this uniaxial crystal, and that is quartz crystal and uniaxial crystal. So, let us consider three mutually perpendicular axes x, y, z in the crystal. So, optics axis is considered along one of the principal axis. X, y, z is a principal axis. So, one of the axis is considered as a optics axis, right. So, velocity or refractive index say along the z axis. So, is the refractive index is say n3 or nz. So, that is along the optics axis. So, z axis if we consider, that is the axis, optics axis. So, velocity or refractive index along the optics axis means along the z axis is different than that along the other two principal axes. So, that is the velocity or refractive index so are same along these two principal axis. Okay. So, z axis is the optics axis. So, its refractive index if it is n3 or velocity v3, other two axes x and y, in these two axes the velocity and refractive index are same. So, that means refractive index n1 along the x axis and refractive index n2 along the y axis. So, they are equal or velocity v1 equal to v2. Okay. So, now this calcite crystal and quartz crystal, there is a difference. Both are uniaxial crystal, but there is a difference. So, quartz crystal is called the positive uniaxial crystal and calcite crystal is called the negative uniaxial crystal. Okay. So, this in case of quartz crystal, refractive index along the x axis along the z axis, that is n3, is greater than refractive index along the x or y axis. So, it is say n1 or n2, they are equal. So, they are equal. Okay. So, n3 is greater than n1 means v3 is less than, velocity is less than v1. So, in case of quartz crystal, velocity along the optics axis is less than the velocity along the x axis or y axis, and in case of calcite crystal, that is called negative uniaxial crystal, it just reverse. Okay. Refractive index along the optics axis n3 is less than n1 or n2, or velocity is along the optics axis is greater than the velocity along the other two directions, that is v1 or v2. Okay. So, that way we differentiate the uniaxial crystal. So, quartz crystal is example of positive uniaxial crystal and calcite crystal is example of negative uniaxial crystal. So, that is defined this way. So, when you view the image due to refraction through the glass, so we say we see one image for a particular one object, right. In case of double crystal, when we view an image through calcite or quartz crystal, we see two images, whereas optically isotropic crystal shows only one image. As I mentioned about the if you see through the glass, so generally we are familiar with this type of refraction. So, that is isotropic medium. So, one object we see one image, but in calcite crystal or quartz crystal we see two images for a particular one object. So, that means these crystals are anisotropic crystal, and this anisotropic crystal, that is why we call them birefringent, because incident light may be doubly refracted. Okay. So, when light enters into uniaxial crystal, it splits into two orthogonal linearly polarized light or rays. Okay. So, when light enters into the uniaxial crystal, so it splits into two orthogonal linearly polarized light or rays. So, one of them is called this O ray and another is called E ray. O ray is ordinary ray and E ray is extraordinary ray. So, if you compare these two rays, their characteristics are, so O ray is basically sigma polarized light. So, sigma polarized light, you know, this basically this dot is the electric field direction, right. It is the perpendicular to this paper, plane of paper, okay, and this is the direction of light. So, now this plane of polarization means the plane contains the direction of light and the electric field vector. Okay. So, in this case, this is this plane perpendicular to the plane of this paper. Okay. So, if this plane of polarization is perpendicular to the plane of incidence means which contain the reflected which contain the incident ray, refracted ray or reflected ray and the normal to the crystal. Okay. Crystal surface where this polarization refraction is happening. So, that is the plane of incidence. So, that plane of incidence, in this case say it is this plane of paper, okay, plane of this paper. So, now plane of polarization is perpendicular to the plane of incidence. So, there is a sigma polarization and O ray is all the time is sigma polarized light. Okay. E ray is the pi polarized light. Okay. So, plane of polarization, this direction of light and the electric component. So, that is parallel to the plane of incidence. Okay. So, in this case this plane of paper is the plane of incidence as well as plane of polarization, because this electric component is as well as this direction of light is on the plane parallel to this paper. Okay. So, this type, so E ray is basically sigma polarized light. Velocity is same in case of O ray ordinary ray, velocity is same in all directions, means refractive index is same in all direction. Okay. Whereas, in case of E ray, velocity depends on the direction, that is refractive index depends on the direction. Okay. Now, for E ray and O ray, velocity or refractive index same for E ray and O ray along the optics axis, but velocity or refractive index are different for O ray and E ray perpendicular to the optics axis. Okay. So, this we can differentiate the O ray and E ray following these characteristics. So, one thing common for both, the velocity or refractive index for O ray and E ray are same along the optics axis. So, then we can define the optics axis, which what is optics axis. So, optics axis in the crystal is the axis in that direction the velocity or refractive index for E ray and O ray are same. Okay. So, that way we define the optics axis. So, these two crystal, for basically this calcite crystal and the quartz crystal, the refractive index, if we use the sodium light, means this is the nearly monochromatic light, sodium D lines, wavelength is 5893 angstrom. For this wavelength, because refractive index depends on wavelength, it varies dispersion basically. So, for this wavelength, refractive index for O ray and E ray in calcite crystal is 1.6584 and 1.4864 respectively, right. So, refractive index for O ray is greater than the refractive index of O ray, E ray. So, refractive index for O ray is greater than the refractive index of E ray in case of calcite crystal, whereas for quartz crystal refractive index for O ray is less than the refractive index of E ray, and this for sodium light, this is the value, okay, 1.5443 and 1.5534. So, for quartz crystal, the velocity of O ray is greater than the velocity of E ray, whereas for calcite crystal, velocity of O ray is less than the velocity of E ray, right. And another thing, the velocity or refractive index are same for O ray and E ray along the optics axis. So, this value are not along the optics axis, right. So, in other direction, right. So, if you consider the velocity in the calcite crystal, for calcite crystal, okay. So, velocity of O ray is less than velocity of E ray, right, and x axis and y axis, they are in that two directions, the is the basically isotropic means velocity will be same in these two directions, but they will be different for O ray and E ray, right. So, In xy plane, in x along x and y direction, in xy plane, if I consider the velocity, draw the velocity, so there will be circle, there will be circle. But velocity of, so this will be bigger circle than the circle for Ore, because velocity for Ore is less than velocity of Ire, right. So, if you consider the z axis and y axis, so in this case for Ore again we know the refractive index or velocity are same in all directions, right, x, y, z directions, right. So, all the time it is basically spherical, we showed this velocity spherical, right. So, here also for Ore, so we will just draw the circle, velocity same in all direction, x, y, z direction, okay. So, it will be circle. Now, velocity is same for Ore and Ire along the optics axis. So, optics axis we have considered along the z axis, right. So, velocity of Ire is basically same as the velocity of Ore. So, immediately we can consider the same velocity of Ore at this direction, but other direction x and y direction, velocity of Ire is greater than the, will be greater than the velocity of Ore. So, you can draw this, it will be ellipsoid, right. So, here also the same, if you instead of y axis if you consider x axis, it will be same, right. So, we can draw the velocity, we can map the velocity of Ore and Ire through the calcite crystal, uniaxial crystal, that is a calcite crystal. So, that is the picture, right. So, if you consider the quartz crystal, so it will be just reverse, right. So, again in case of quartz crystal, so only this you are seeing the change, this one is now velocity of Ire is less than the velocity of Ore, right. Now, this red one is inside, red one was outside, that is for Ire. So, now for Ire this sphere or this circle is inside, and for Ore green one, this is the outside, bigger circle, bigger sphere, right. So, z axis velocity will be same, in other direction x or y direction velocity are different, and velocity will be just reverse of that, velocity of Ire is less than the velocity of Ore, right. So, here also velocity we have to keep here this velocity higher one, because the velocity of Ore is same in all directions. So, that condition we have to fulfill. So, then this velocity of Ire is along the x and y direction is less than the Ore. So, you will see the ellipsoid, ellipse like this, okay. This if you change x or y, so it will remain same, okay. So, for quartz crystal and the calcite crystal, these are the map for the velocity distribution inside the crystal, okay. So, it is nothing but the velocity, it is nothing but the similar mapping of the refractive index, okay. So, just whatever velocity higher, so refractive index will be lower, okay. Just opposite way you have to draw. So, since this C is constant, so they are inverse, okay. So, they are inverse, C is velocity in vacuum, okay. So, whatever here we have drawn, so this is nothing but the either is velocity or opposite way it is refractive index distribution in the crystal, right. So, I will continue this discussion in the next class. There are lot of things to tell you. So, I will stop the discussion here. Thank you for your attention.